Well, welcome everyone to the Soil Wealth and Integrated Crop Protection webinar. Today, getting the best out of compost. My name's Carl Larson from RMCG, and we're lucky to be joined by my colleagues down in Tasmania, Donna Lucas on the left, Doris Blaesing in the middle, and Sophie Lapsley. So today we're going to be talking about compost, the good, the bad, the ugly. But before we do get started, just a few housekeeping notes. You'll notice on the right-hand panel, you've got your go-to webinar controls. You can see who else is on the line with the attendees block. There's also your audio and webcam there, which I've currently got muted for everyone just to limit background noise. There you can also see a range of handouts which we've got available which are related to compost. So we've got a couple of fact sheets there, one for growers, one for producers, which were developed by AHR, MRA and EPA New South Wales along with Freshcare. There's also a great case study from Boldivers Farms in WA, and also the Australian standards for compost, which are touched on later in the presentation. If throughout the webinar you wanted to raise a question, you're more than welcome to do so in the question pane on that control panel. So if you type those through, they get sent through to me, and I'll gather those up during the webinar, and we'll have a bit of Q&A as we go through. So we've got an hour. Our aim is to finish within about 50 to 55 minutes with questions interspersed throughout. So what are we going to cover today? We'll be starting with Doris on what are composts, and also aspects of compost. And I mentioned before the good, the bad, and the ugly, and it's a really nice, easy to remember frame to think about composts and how they do fit with vegetable production systems. Doris will then hand over to Sophie to talk about compost and soil microbiology, which is a really fascinating area, and Donna's then going to cover off on the economic considerations, using some examples of the network of 14 demo sites we've got around the country as part of the projects. Before we do make a start though, I'd just like to do a quick poll on how much experience those people on the webinar have with using compost in commercial vegetable production systems. So if you'd like to now, you can use your poll there to click one of the options there. Lots, a bit, not much, none, but keen to find out more, and hopefully we can address that today. And I'm seeing some really interesting answers come through. So looking at those results, we've got quite a nice band with a bit and not much knowledge. Some people with lots of knowledge, so 17% of us have used compost quite a bit, and it'd be great to draw on your experiences throughout this session as well. But good to see we've got a fifth of us with none and keen to find out more. So a really nice even spread. So without further ado, I'd like to hand over to Doris now, who will take us through the first part of the webinar. Over to you, Doris.
Yeah, I want to be very brief about some of the basics, especially for people, the 70% who know a lot, and for the others, this webinar will be recorded, so you can always go back and reread the slides for reference. Probably one of the things I would like to highlight in this slide is that we need a correct composting process, and probably two words on there is pasteurized and stabilized. And from my experience, sometimes composts are used that are not pasteurized well or not stabilized well. So we'll learn a bit about that in the following webinar. And again, compost sources, I highlighted there which one could have a risk of human pathogens. Probably people think or forget about municipal wastes. There could be a risk because often it can contain grass clippings or food wastes. So we should think about that. But there are also, of course, wood and paper, textiles, and sometimes we find actually something in the compost which is not biodegradable because some household waste is not well separated. But by now the compost producers, the professional guys anyway, do have a way of getting foreign bodies out of the compost. So again, that's something to look after. Composts are made out of, as you could see in the previous slide, a lot of different ingredients, and depending on the ingredients, you get different composts. So these, especially the microbial levels, we can have fantastic stuff, and Sophie will talk about that. And we have some ugly stuff like human pathogens, and we will touch on that as well, and how we can make sure that there are no risks. Another thing is, of course, depending on the feedstock, there could be some contaminants. And again, if you know what's in there, you can handle it. So we just want to highlight, the variability or potential variability of compost. Probably the methods are also quite interesting, and maybe some of the people who are listening today can actually put more light on that in the discussion, but there's certainly different composting methods. Very important are temperature, humidity, oxygen supply. Obviously, we want to really have aerobic conditions, and the comment time is on your side really refers to the pathogens in compost. So if you leave it longer, they're more likely to disappear. The founder is actually from Calfresh, so one of the large vegetable producers using compost and making compost. As you can see, it looks all very nice. It takes up a lot of space. And Rob Hendrickson actually is using mushroom compost as a base. So he's lucky to be able to produce compost very quickly and very evenly. So that's just on the side. So we go to the next one. So the opportunities with compost are great. So you can end up with much better soil structure. So, the soil acts more like a sponge than without the added organic matter. There will be more air. Having more air, you will get better root systems and more diverse soil life. To me, the roots belong to the soil life. In a nutrient cycling works much better, and usually we observe better crop health. And Donna will show a good example of that. And it should, if things are done right, reduce the input costs of other management inputs. And we've seen some of that with people who get it right. So that's definitely very good news. Then another really good aspect, of course, of using compost, and the reason why a lot of people do use compost, is the microbiology. So over to Sophie on that.
Thank you. My part of the topic today is to talk about compost and its relation to the soil microbiology and how it helps. And again, I'd like to say that it's when we're talking about good soil microbiology. So what the compost does is it provides structure to the soil and helps the soil microbe habitat. But a lot of people ask the question, well, how does improved structure benefit soil microbes? And I like to liken it to people in cities. And if you have a group of people who are put in a nice area, they've got nice homes and they thrive and they work well together. But if you take that group of people and put them in the desert, they're likely to wither and fade away. And it's exactly the same with your soil microbiology. But then a lot of people say, well, how does that benefit my crop? Improved structure helps the microbes, if they're healthy, transfer nutrients to the plants. They aerate the soil, so you've got better water capacity holding. They help support the plants to give you a better, healthier crop. Compost help increase soil micro numbers and diversity, so this is a good one. A lot of people though ask, is it quicker to add microbes directly to the soil? Again, if we liken it to people in a city, if you take microbes and add them to an area where you haven't got the resources, it doesn't work. So by adding your microbes in the compost, you're providing them with the food source. They thrive better and they start working quicker. another question people often ask is, well, can we just add specific microbes that might be missing? This is a very hard one, as microbes all work together, and it's a very complex issue. If you start adding just one microbe at a time, there is a reason for microbes being present in your soil, and that's due to the conditions in your soil. If you just pick one specific microbe and deposit it in your soil conditions, it may not work. And I've seen that on a regular basis where people have trialled products and said it hasn't worked. And quite often that can be because they've put it in the wrong environment. The important thing then is to know, well, what's already in my soil, and the best way is to have this tested. So compost can help reduce the nasty pathogenic microbes as well. How can compost achieve this? It's a matter of competition, and you see this in hospitals. When you start to take out all the different strains, you end up with one superbug, and this can also happen in the soils. So by putting on compost with a very diverse range of microbes, you help suppress the nasties, and they can't actually then take over. Again, you need to know that the compost is of good quality and what is in it. So have this tested, and it's best to have this tested against the standards. And as Carl said earlier, you can find the standards attached to this webinar. So in all, and as stated before, it improves soil structure, available food source for your microbes, and thus increasing microbe numbers and diversity, which can then reduce your pathogens. All this leads to your increased crop health and the potential for a more marketable yield.
We have a few examples in the economic session on that. So what Sophie and we talk about is based on our experience and not on textbooks. I mean, there are good textbooks on compost as well. Sophie already alluded to some of the challenges, and I think variability is one of the big ones. I've seen it quite often that somebody says, should I use this compost, and here's the analysis. And the analysis might be 10 years out of some kind of, what did Sophie say, Hollywood compost, so that's the showcase. And it might be not a compost that is available at the moment. So that's probably a good way of actually checking what you're actually getting and make sure the testing is complete and not something is missing. And again, there is actually a standard on what should be tested in compost. So it's also an Australian standard. We might actually be able to put that on our website as well. It's currently not there. Using too much compost at once, we all think more is better. So if 1 beer is nice, 5 are better. However, with compost, you really have to be careful to not overdo it and bring things out of balance. So it's probably better to start slowly and add more as you go along. Variability in the unknown feedstock can be an issue. I would always ask, what is this compost made of? Knowing that all kinds of things can happen in compost. And the good compost maker should be able to make you a specific compost for your purpose. I've seen, especially if you get compost that's a bit wet, it gets quite lumpy and ugly to spread, costs you a lot of money to spread, but also the effect is going to be quite uneven. Another issue is that if you don't know what's in it, you can't actually manage the nutritional aspect. And in our trials, and if you do trials on farms, you're having certain areas composted and others not, and you still have to use the standard nutrition and irrigation, your results will be a little bit skewed because in principle you should adjust nutrition and irrigation with the use of compost. So there's a bit of a challenge in trying it, but some of our largest growers have overcome that. And probably one of the big challenges is transport and spreading. Some people are quite far away from a good compost source. But again, over time that might change because I can see compost being used more widely in the future. Problems, one of the problems is, and we don't get that here as much as, for instance, in the US, is leaching out of compost piles or leaching out of paddocks into farm dams or into rivers and streams. I don't think at the moment it's an issue, but we thought we'd be mentioning it. Again, compost can release more greenhouse gases if it's not, especially if it's oversupplied. But I guess the biggest issue that can arise is food safety. And we might all remember last year we had a food safety scare with one, and we're not really sure. There's different stories where it came from, but definitely you have to be careful with using composts on produce that is eaten raw and is in contact with soil. So baby leaf lettuces. There are guidelines and there are food safety guidelines which you can follow. I personally would even be more careful, but it's everybody's decision. But certainly have a look at the guidelines. Another risk is, of course, contaminants. Again, get it checked. A good compost will have now a minimum contaminants. And also, if the compost is done properly, there won't be any weed issues or impurities. And again, depends on where you use it. You don't want to, in an orchard, a certain small level of impurities might be alright, but not in a lettuce crop. So personally, growing vegetables, I would want to know what I put on my land. So I would want to know, what comes, and I guess every compost producer will have that information. So you would want to know what's gone in, how it is treated, and you don't want to have it too wet because it's you pay for the transport. And then, of course, you want to really have a proper analysis, which is the analysis according to the Australian standard or equivalent. So it would be also good to actually ask a supplier of a product specification, like you get with fertilizers, you get a product label. So it would be good to get something similar from about your compost. So there are some just a brief summarizing of the Australian standard. So this is only about the pasteurization. A good compost takes a bit more than 3 days or even 6 weeks that it could use in the first process. So Sophie, from your experience, how long does a good compost take to make?
Anything up from, I'd say about 3 months actually. And as Doris mentioned earlier, the longer you can leave it, the better. Having said that, obviously, if it isn't a good compost, the longer you leave it, you can actually make your problems worse. But certainly, I'd be looking to 3 months or above.
So, in your experience, what is a not good compost? What you've seen?
A lot of not good compost that I'd tested and seen were having high pathogens and anaerobic, so you could actually smell it. And to me, the first thing I'll do is smell a compost. There should be no bad odour to it. That indicates anaerobic bacteria, which also can indicate pathogens as well.
So it's good, trust your nose.
That's it.
Okay. Yeah, I think it's a good, having been on some of the composting sites in Australia, it usually smells pretty good there, so that's great. Again, as it said there, if you don't know the feedstocks, it would be better to have, a longer heat treatment rather than shorter.
Yes.
I've also on the next slide just added for your reference. There are a lot of other conditions that are acceptable under European standards in the UK. So I thought I might as well list other times and temperatures that are possible. Even though I guess Savia, you might want to comment on the 70 degrees for 1 hour.
Yeah, I was hesitant with that one. From what I've seen of products that have been treated like this and tested, it is not long enough to actually kill off any pathogenic microbes and to actually complete the process. So it becomes out quite a raw compost.
So could you then compost that further in a pile system?
Yes, you can take that further and put it in a pile. Yeah.
Is that because it doesn't reach that 70 degrees right through consistently? Or?
Yeah, quite often this process in vessels, you don't get the heat on the outside of the vessel, only in the centre. So dependent on where you test, in the centre it may have killed off everything, but on the outside it doesn't because it's too quick for the whole vessel to reach the 70.
Makes sense.
Yeah.
Okay. Next one. So this is just guidance. It's actually not much guidance for composts and human pathogens. So the figures you've seen there I actually took from the biosolids guidelines grade A. So biosolids grade A, even though, for instance, the food safety guidelines really don't recommend using biosolid products on vegetables, whereas in the biosolids guidelines, grade A product can be used as unrestricted use. I think there's a limit again for vegetables eaten raw The interesting thing is vegetables eaten raw. In the guidelines, there actually are examples. And beetroot is classified as low risk. We know all that by now. People eat the beetroot in juices and they're not peeled, and in a juice bar. So it's the same with ginger. Ginger is now used a lot in juice bars and it's not peeled. So eating habits have changed and the risks have changed. So just think about, it's not only the lettuce. Anything grown in soil you might be a bit careful. So anyway, I thought I let people know about the limits that I could find that could apply to compost. Again, there are all the...
got a comment from Virginia Brunton. Just in New South Wales, the regulations require testing for pathogens rather than just relying on the time records. So thanks, Virginia, for sending that through as well.
I actually think the EPA in Victoria also has relatively new guidelines that also look at human pathogens. So wherever you are in each state, just make sure you keep yourselves up to date with what the recycled organics and EPA websites for information.
Okay, so the economics of using compost or other practices is really about assessing the benefits and also assessing the costs and then weighing up whether there's a net benefit for you. And Doris has already talked about some of the main benefits of using compost, like increased organic matter, better root growth, better soil life. And Sophie talked about how compost can be used to feed the microbes in the soil. And I think feeding the microbes in the soil, feeding the soil biology is really invaluable. So from an economic point of view, it's priceless. But we know that as vegetable growers, we also need to make sure that our crops are economic as well. So what I'll show you is some data from some of the soil wealth integrated crop protection demo sites and case studies. But before I show you that data, it's probably worth mentioning that data from one site cannot always be directly translated to another site. So each site is quite specific. And the other thing that I wanted to point out too is that when you start using compost, if you're new to using compost, there's probably some other changes you need to make if you want to reach the full economic benefit of using the compost. So, for example, there might be an opportunity to reduce your tillage costs, or there might be an opportunity to reduce your irrigation costs, but you need to make those changes if you want to realise that full economic benefit. So the first case study is from Western Australia, and this is in a carrot crop. And in this case, the cost of the compost delivered and applied at the site was $2,200 per hectare. So it's a substantial cost per hectare. We've got some photos there of the carrots that were grown with and without compost. I might come back to those in just a minute. Then when we look at the benefits at this site, this grower saw yield increases of 30%, which is quite substantial. And they also found that through using composts, they didn't need to use fumigants anymore. So there was another saving there from using not needing to use fumigants. They've also been able to reduce their fertiliser by about 10%. So those benefits alone have well and truly produced a net benefit for that grower. But in addition to that, they've also noticed that the beds are more stable. There's less greening of the carrots on the shoulders, and the carrots are easier to harvest. So there's potentially reduced harvest costs there as well. And they've also noticed reduced sandblasting in the young seedlings. And if you have a look at the...
Sorry to interrupt there. One of the questions we get quite often from growers is how long you have to wait to get these benefits. What time period was that over, those benefits you just ran through then?
This farm has been using compost for a number of years. Doris, have we got
nearly up to 10 years. So it's Sam Calamari who decided he wants to actually try compost against untreated. So he actually has a trial paddock where he has half of it is only treated with compost and half of it is your business as usual using mesosodium and normal inputs. So he's been finding benefits also in his potato crops, and even like a potato carrot rotation is actually quite challenging, and he could breed diseases, but it seems that in his compost rotation he's actually managing that really well. So he's been using compost on the same paddock more than once. So he's keeping up, he's using lower inputs but more often. And
yeah, and you can see from the photo where there was no compost used on the shoulders of the bed, the carrots are kind of all leaning sideways, so difficult to harvest. They're more exposed, so that yeah, and you can see the condition of the beds.
Yes, there would be a carry-on effect, harvesting carrots, for instance, with green shoulders, on the grading line as well, because you need to spend more money to actually sort out the ugly ones.
So I guess we can see from this particular case study there was definitely an economic benefit, but some of the questions are, would those benefits continue over time? But then on the other hand, if you don't use compost, does that mean that your yields might decline over time? So sometimes by using compost you can maintain yields, for example, and we've also already talked about the question about how many years did they use compost at that farm.
And Donna, we've just got another question in from Virginia, just asking around the nutrient analysis for the compost used, and how are the application rates decided? Do we have any information on that?
Yeah, it was actually decided in cooperation with the supplier to the and the farmer. They've sat down and nutted out which quality of compost to use, how much and how often. So I think it should be included in the case study, because that's the case study you mentioned earlier, Kyle, which is on the website. If it's not in there, I can follow up more details, but it's certainly been with a lot of input from the compost producer this trial.
Great. So our advice, Virginia, would just be to download that case study in the handouts pane there for some further info, or we're happy to follow up out of session.
Yep, definitely.
Yeah. And the second case study kind of follows on from that question, actually, because this is one of our soil wealth ICP demo sites, again in WA and in carrots. And here we've used a couple of different types of compost at 2 different rates. So depending on the compost and the rate, the cost of the compost, including the transport to the site and application costs, ranges between $2,000 per hectare and $4,500 per hectare. So you can see at the higher application rates, it's quite a substantial cost per hectare.
And they're both very good compost, so they're quite aged, which makes it more expensive.
Yeah. And the benefits at this site, and this is from one year, so there were no real differences in the yield. So we didn't see a marketable yield benefit from using the compost in the first year. There was a change in the distribution of the carrot sizes, so potentially there could be some increased income from using the compost if you can have more carrots within that desirable size range. And at this site we did some soil tests to look at DNA assays. So we found that in the soil where we use the compost, there was a lower incidence of soil-borne diseases or soil-borne pathogens that can cause diseases. So although we might not have noticed a benefit in the first year, there could be some benefits in the subsequent crops and over a number of years.
And that was the target for this target question, is how can we reduce the incidence of Pythium specifically. And the DNA test is actually under development by SARDI. So SARDI has been very helpful actually testing for us and also developing the test with our site. So that's a great cooperation between the different projects. And we're quite excited about this test.
So at this particular site, in that first year, you could say that there's no economic return in year one. And the reason for that is the transport costs at this particular site are quite high, because it's a long distance from the compost. There were only modest benefits from the yield or quality improvements, and while there would be some fertiliser savings if you changed your fertiliser practices, it still wouldn't cover the full cost of the compost. But the question is, what are those longer term benefits from using the compost? And also, could you use a different rate? So, could you reduce the cost of the compost and still achieve what you're trying to achieve?
So we are still working with that site, and we'll follow up. There's already a new carrot crop in there. So this one was harvested late last year, and it's already has carrots growing again. And that's the issue: is the close rotation, the lack of having other plants. That's why compost is valuable.
Yeah, and I guess it also highlights that when you're evaluating compost or other practices, that you really need to look over a whole rotation in a number of years.
You also haven't actually calculated there the methyl that is not necessary anymore.
Okay. So the third case study, this is one of our demo sites in North Queensland, and this site is managed by AHR, Applied Horticultural Research, and we've used compost on a capsicum crop, and we've also used compost in combination with cover crops and beneficial bacteria. And you can see from the table there that using compost alone, we've increased the yield, and the overall economic benefit in 1 year was $5,360 per hectare. So that's a really good really good result. But when we combined it with cover crops and also beneficial bacteria, the benefits were even larger because the yield increased even further. And the other thing I wanted to highlight at this particular site was AHR also did some assessments on the post-harvest quality of the capsicums, and they found that using some of these practices also improved the quality of the produce and the shelf life. So that's just a reminder or highlights that we also need to take into account those post-harvest costs, because it might mean you've got less waste throughout the supply chain, and also you might be able to reduce your post-harvest handling costs as well.
So Donna, just for those that can't see the captions on those 4 images at the bottom of the slide, would you mind us running through those left to right and explaining what we're looking at there?
Okay, this first one here is the conventional practice or the control, and this is 7 days post-mature red harvest.
So it's a post-harvest dry. Okay, because I thought, oh, you wouldn't harvest that bit. Okay.
The second one here is the compost alone treatment. The third one is compost plus cover crops, and then the fourth one is the compost plus cover crops as well as beneficial bacteria. So you can particularly see in the last 2 images a real improvement in the quality of the crop.
We've also got a question through from Ashley Burgess, just asking, is there a cost benefit when compost is applied to high organic matter soils, for example, peat soils?
We don't have any examples in our demo sites.
But maybe Sophie, you want to answer that?
Yeah, unfortunately, I mean, it's the results you get from the compost vary depending on what you're putting it on. A lot of the gains are from adding organic matter and carbon to the soil. So, of course, sandy soils are going to see, for that perspective, a marked increase, whereas the peat soils wouldn't. By adding microbes, though, you do see a benefit, but it possibly would not be as great as if you're adding it to a sandier, dry soil.
Would it depend on the purpose for using it? If we're
It
thinking
is,
about disease suppression.
So, I mean, compost, you're adding compost for a whole multitude of reasons, and what you've got to work out in your case, why are you actually adding the compost? If you are adding it for the organic matter and the carbon content, it's possibly not the right solution for peat soils. If you're adding it for microbiology, then yes, it would be.
Yeah. And I've seen some of the high organic matter soils actually being quite compacted. For instance, in the Kubi-Rub area where there's heavy cropping, so adding compost might help against the compaction.
Yes.
So I probably would use personally low rides of a good quality compost and probably combine it with cover crops.
Yes.
And then also check out that the fertilizer regime is adjusted.
So that's good advice. Thanks, Ashley, for your question. If that answers it, great. If you wanted to follow up, please let us know and we can have a bit more of a discussion about that. It's a good question. Okay,
the fourth case study is from Cowra in New South Wales, and again this is a site that's managed by AHR. And at this site we've used compost and then grown spinach, and you can see from the table there that we saw an increase in yield of 22% in the spinach when it followed compost compared to the fallow control. But in this particular case, the response to the compost is most likely a response to nitrogen from the compost, and I'm saying nitrogen deliberately here. Often it's other nutrients as well, but in this particular site we've used cover crops as well, and we noticed that the legume cover crops resulted in increased yield. So it's most likely the yield response here relates to a response to the nitrogen from the compost, even in the first year. Because the control here, there was no nitrogen fertiliser applied, or it was only a small amount. So you could argue, when you look at this data, that perhaps a cheaper option to achieve the same yield would be to use nitrogen fertiliser. On the other hand, you don't get those longer term benefits from the improved soil structure and improved soil health.
Yeah, I don't even 100% agree with that, because if you use mineral fertiliser, you don't get all the other microbial benefits, which in a legume crop you still have.
That's right. So
it would be really interesting, I guess, in this kind of studies. Unfortunately, there's a limited budget to actually do the microbiology testing. Would be interesting, but we always hit the wall with our finances.
Yeah.
So we sometimes create better questions, not all the answers.
I guess this site also highlights that when you're conducting a trial on farm, you need to make sure you're comparing apples with apples as well.
Which is sometimes difficult, but also, like for instance, in most of these trials, we at least have replicated strips through the padding, not just one. So each treatment is at least replicated once.
And speaking of good questions, we've had a great question from Luke Hargraves, and I might put this to all the panel. Is there a marked difference in results between higher and lower rates of compost application, and is the compost being incorporated? If so, to what depth?
Have you seen differences just from the testing that you've done on the high and low rates? I've got an opinion on it.
And it's purely from the testing that I've done, and this doesn't include incorporation. Again, it is dependent on what it is going on, which has influenced the results to it.
I mean, I've seen people using something like 10 or 20 tons per hectare, and was actually aghast of why you would want to do that, because I've seen good results for people using compost, or also things like chicken manure, using something like 1 to 2 tons per hectare, but quite regularly. And usually people did incorporate it into the main root zone, which is, most crops 30 centimeters. But I've also seen good results when we did trials for compost in orchards, where we just basically sprinkled it on the soil surface, and really only about a centimeter max, and still got really quite nice changes, even in the quality of the fruit, which surprised me, because I thought we were doing a bit of humbug. But it really was one of the first involvement I had with compost, and I was quite surprised that small amounts made a big difference. But again, we actually had an orchard which was in reasonably good condition.
Yeah.
We found when we use anything like microbes or compost, and the soil is already very challenged, like as I would say, like a desert, it is harder to get it back. But compost certainly helps, and then compost together with a cover crop. Where with a cover crop you also get more helpers through root channels and critters and worms. It will actually get worked into the soil as well. So for that picture in Cowra, these guys are using minimum tillage, so they still get the compost benefits.
So another question from Peter Harrison. Donna, just building on your last point there on the slide for case study 4, Peter's just mentioned why are we so sure unless there's been an N analysis, so that nitrogen's mostly organic, which may not be available, and was just a question about how much per hectare, or the application rates of compost for this particular example.
I don't have the application rates with me, but we can look that up and get back to them.
You can also put it on that slide.
Yeah, we can add it to this slide actually.
Yeah.
Now I think there was some soil analysis done at this site.
Yeah, there was.
So we've come to that conclusion based on a number of different things that were measured at the site.
So we could actually maybe can write this up as a brief case study. The idea is we already have the case study. The Centre West export is nearly there, so there will be a case study on that side, so we can keep going and actually give more information in these case studies on our website.
Just one last comment before we move on, Donna, just from Virginia Brunton again, was just comparing compost rates might be difficult unless you're characterising nutritional content and cross-comparing tonnes per hectare versus cubic metres per hectare. So just a good note there in terms of comparing the apples with apples from Virginia. Thanks for that.
Yeah. But so the rule more is better does not really apply with compost usually. I've also seen, even with good compost, and to somebody using a lot and actually encourage the microbiology to a degree that it actually took nutrients away from the crop. So we monitored the crop and the soil quite actually, Sophie did some of the analysis, and we suddenly realized that the high rates of manure compost that was in that case did actually grow some microbes that are competing with the crop, which was an interesting experience.
That is right. It's a very complex issue, and I guess the best example I can give is you can actually use molasses mixed with water as a weed killer. And what that does is it causes a bacteria bloom in your soil, which takes up all the nitrogen, and your grass can't grow. So that's a specific example of actually, if you make your microbes in your soil grow too quickly, too fast, it can be detrimental to the crop.
Okay, so just to sum up on the economics, I guess when you're assessing the economics of using compost, it's really important to consider what your main purpose or reason for using the compost, so you know what to assess. And there's also possibly another range of other practices that need to be changed if you really want to maximise the economic benefits. So in terms of nutrition management, making sure the crop's got balanced nutrition, the tillage management and irrigation, for example. Also, we need to consider the short-term benefits, so from the crops that we're growing, but also those longer-term benefits. And something we didn't really talk about much is the kind of risk management benefits. So if you've got soil that's better structured, your beds might hold together better. If you get a heavy rainfall event or a flood, for example, you're more likely to have lower levels of damage. So there'll be some cost savings there. And you can even estimate what that might be. If you know that in your region every 9 or 10 years you get a major flood, you'll know what that costs in terms of loss of your crop, reforming beds. So maybe through using compost and or cover crops and other practices, you can reduce those costs.
Certainly feedback from Calfresh is, they were flooded and suddenly after they changed their soil management, the bean crop that usually would have been drowned kind of shook itself slightly and was harvested again. There's no loss compared to a complete loss that was expected. So there's certainly some examples where growers experienced a really good risk management benefit.
Yeah, and then the other reminder there is that the costs and the risks and the benefits will vary with every situation. Depends on the compost, depends on your own conditions and different cost structures. For example, if you've got a larger scale, you might be able to get a discount to the rate for the compost. You might have different transport costs and different machinery costs.
So Donna, just to finish up that slide, there's a couple of comments that have come through and then we've got a question to finish off on those case studies. Firstly, just Peter Harrison saying, off the back of Doris's comment before, more is generally not better. As a rule, Peter's using 20 to 30 tonnes per hectare. So thanks for that, Peter. And then Hilton Henning from Macquarie Franklin has just mentioned that dry density is a characteristic of many organic products that's often not provided and not understood as important by both producers and users. So nutrient content cannot be calculated without this info. So thanks for sending that through, Hilton. And Donna, just a question to you off the back of the Bowen demo site. Was the trial replicated and were any of the results statistically significantly greater than the control?
I'll have to check with the data that was put together with that site, and we'll put it onto the slide when we post it up onto the site. Yep. Because some of our demo sites have been replicated and others haven't.
Okay. That's probably the real challenge in the work we're doing is to have one replicated trial or several, they're only replicated twice. So we've gone for the demo site so we can get more information generally, but it's often not statistically analysed. So that's why it's good and maybe there's more of a need to share learnings from different people.
Okay, Doris.
So I mean, really to sum up is, it is probably important if you don't want to compost on farm, and if you do that, you have to take it seriously and get advice to do so. But it's good to actually find a supplier that you can develop a relationship with, so you understand each other's needs and what you want to do. Certainly getting the information about the compost product. I personally, growing high-risk vegetables, I would put prescribed waste or manures not straight ahead of that crop. There are usually options in putting it ahead of a cover crop. I know the ginger industry does that. They use compost, then put a cover crop in, and then grow ginger. So just to keep the risk low. There is probably, we only gave 3 websites. There's a lot of information on compost, and that's probably there's a lot of complexity and a lot of uncertainty around compost. So the more information you gather about the product and your site and your needs and the purpose, you lower the uncertainty, but there is always the complexity there that you have to work out on a specific farm what works best.
Doris, just a comment that's been provided by Virginia is just be aware that the Australian standard 4454 does not provide nutritional analysis. This needs to be provided by the manufacturer, so a good reminder there.
Yep. Yep. It also doesn't, not the standard, I don't think, asked for the human pathogen analysis, but as we heard, the EPI, the new EPI regulations do it. And I think the larger compost producers are actually in communication with each other, and they do make a huge effort to do the right thing. So that has changed, I think, in the last 10 years. We've got some fantastic producers out there. So there's a lot of good, there's a little bit bad, and you just have to watch the ugly. Everything has got an ugly side, so you just have to watch out for it. So in principle, I think compost is a good, fantastic resource we should use better. And of course, one thing I want to say that all this demo site work, especially with the compost, is not possible without the growers who actually are prepared to do large-scale trials. We've got advisors and compost producers helping us in a big way, also supplying a huge amount of compost at their cost. So there has been quite an effort going into getting these things together. So I want to thank all the people. I guess I hopefully know who they are if they're listening. Otherwise, we wouldn't have enough slides to name them all. So thanks to all the helpers.
Oh, that's great. So, we've got a few more questions coming through, and we might open that up to everyone else. If there was points along the way that you wanted clarification on or a bit more information, now's the time to raise your hand and put a question in. We've got a comment from Peter Harrison just saying an impediment to compost use is actually, or can be, the application equipment available for effective spreading, the physical doing. I mean, I might phrase that in a bit of a question. What have you seen with the demo sites around the country? What are people using? How are they incorporating it?
Well, for instance, in WA, we had the farmer, the business had a spreader, and we were quite confident that that would work. But then when the compost, it was a very fine compost because of the carrots, it was well composted. It took, unfortunately, 2 days, so the farm manager spent 2 days spreading the compost. That is absolutely not right, but he was quite prepared to change his machine because he knew from the pine that he had what he had to do. So it is a real issue, and actually there are people who are also now working on machines where you can bend place compost, and even some efforts to pelletize compost to actually use the minimum amount put into the root zone. And we haven't even talked about some of the liquid products you can take off compost to also actually apply to the root zone. So there's a lot we have to learn. But there are, I agree, maybe we should have an exchange Facebook site about equipment, because that's where we get stuck with a lot of things we're trying to do with cover crops, compost application, mulching. So there's a lot we have to learn, and a lot of opportunities for machinery producers to actually help. So if there's any comments on people now, what's the best way, we would be happy to hear that or see photos.
Oh, that'd be great. We've actually got a follow-up comment off the back of the Australian standards discussion before, again from Virginia, who's been furiously flicking through that or nose it back to front, that just a clarifying comment that AS 4454 does have pathogen limits in it. So thanks for that, Virginia. We've got another, I guess, comment and rule of thumb from Hilton Henning, who calculates suitable rates of compost application based on limiting nutrients, often using phosphorus and applying, say, 30 kilos of phosphorus per hectare per year, and also the ratio of ammonia to nitrate as a measure of compost maturity, consistently 12 weeks to achieve this. I'd be interested in some comments from the panel on that. what they've found at other sites, and is that a good approach?
Well, what do you think? Using a equivalence of phosphorus.
I'm not sure on the phosphorus suggestion, whether that would be appropriate for all composts.
Yeah, some composts might be quite low in phosphorus, so you would have to use a lot to get the phosphorus levels, your 30 kilograms per hectare. It would be good to have the analysis and say, well, we want to limit maybe to 30, but you can get benefits from compost without having the higher phosphorus levels. So if manure isn't in the compost, you might never get to the high phosphorus levels.
That's right, yeah.
So it might be good to have a microbial indicator, but I like the ammonium nitrate. And again,
it's a good idea.
Looking at certain nutrients, and if the grower is after the nutrients, that is a way of doing it. I think we just have to be flexible in our thinking and think about the purpose in a way of making a good decision. So there's not one fits all.
And we've got quite a bit of interest and comments coming through on the standards. Also from Andy Gulliver over in Western Australia, just bearing in mind that the standard doesn't tell you how good a compost is, it tells you how bad it isn't. And a follow-up comment, the standard itself is not a fit-for-purpose standard, but can be used to develop a fit-for-purpose product. So thanks for those couple of clarifications and jumping in there, Andy, as well. I might just go to a question from Cordelia McDougall, which is great from the grower perspective. To the panel, just to clarify, should you not sow root crops or salad crops directly into composted soils?
Well, from the food safety perspective, I would make sure there's a pathogen test done, or I have reassurance that there's now, there are no human pathogens, or the risk is very low. So the feedstocks will determine how low or high the risk is. That would be the first instance. Animal manures are high risk, but then if the compost is matured and stabilized, I would think the risk is very low. And then also maybe a baby leaf crop, which is very fast, probably bears more risk than a iceberg lettuce crop, which probably is fast enough. So with all the literature I've read, still there is a lot of kerfuffle going on in the US. There is a guideline level saying it should be 120 days between planting and harvest after manures. In Europe, it is a much longer period, so it would be probably 200 days. But again, it depends a little bit on the climate and the exposure. So personally, I would take as little risk as possible. So certainly when you want to use lettuce crops or beetroot or carrots and use compost before, use a well-pasteurized and stabilized compost. And avoid fresh animal manure at all costs, I think.
So is it worth referring to the on-farm food safety guidelines?
Yeah, I mean, there are guidelines for new Australian food safety guidelines that also talk about the use of compost and manures, and then people have to, from there, decide whether they want to be more careful or not.
Yeah, I think some specific crops have their own guidelines.
Yes.
As well.
Yeah. For instance, sprouts have their own guidelines because there seem to be very good collection points for human pathogens. It is very hard to make a fire. Even you could test for E. coli and Salmonella, and levels are low, but there could be other issues with a product. For instance, I don't like the grass clippings from city parks because of the potential of dog contamination. So you just have to really know where the stuff comes from.
That's a good reminder. Thanks, Doris.
And the compost producers themselves would give good advice on this. Because it's not in their interest to contaminate crops.
No, that's right. Just a follow-up comment from Peter Harrison, just around crop types and perhaps looking to other industries, and he had a comment around the vineyard industry's got applications of compost sorted better than most, but noting they've also been doing it a bit longer than others as well. So it's useful to, I guess, look outside veggies and see what other industries are doing as well. And there was a comment following on from our machinery discussion and application earlier from Virginia, just mentioning that manure spreaders with belts and etc. work really well. Fertiliser spreaders with hoppers do not, as material compacts in the hopper itself.
Yeah, we did have a manure spreader in WA, so the manure spreader in WA still needs some modification. It worked as hard, but it was still a pain for, because the product was bridging. Because it was a fine product.
Well, look, thank you very much to our panel, to Donna, Doris and Sophie for their presentation, and thanks also to everyone that's attended and provided those questions. I think it's been a really good discussion. We've got to all of the questions, which is great, and those that we didn't have answers to directly, I think there was 2. We might just follow up with a few notes in the slide. A reminder that the recording of this and the presentation will be distributed after the webinar and also available on the Soil Wealth ICP website, which is soilwealth.com.au. Also a reminder that we've got the handouts there, the standards, Australian standards, which we've talked about quite a bit, a couple of fact sheets for producers and users, and also that compost case study, the 10-year one at Balditis Farms in WA, which is great. And if there are any other resources that you'd like to get a hold of, if it's in relation to compost or soil management in general in veggies, feel free to visit the Soil Wealth website as well. It's a treasure trove of info, along with things like more information on the actual demonstration sites, other events and webinars that we've got coming up. So I'm conscious of time. We've pretty much run up into the full 60 minutes and conscious that people have to get on with their day. But look, thank you once again, and we'll distribute this recording very shortly. So thanks very much, everyone.
Thank you.
Thank you.
Thank you.